It was going on, guys, KIM-1 here. So after completing the Chrome DINO game and Mario walking across the LCD screen of my CMK computer, I decided to go for a real challenge, and now I'm trying to implement a chess program that is supposed to be running on this hardware. And here already I'm running into really lots of issues, and one of the most significant one is I'm horribly running out of memory. And bear in mind the fact that Arduino Nano that CMK computer is based on, so there is the imaginary CPU emulator running on Arduino Nano, and I only have 2 kilobytes of RAM on Arduino Nano, and initially the emulator RAM was the size of 1K of RAM. However, recently, like today basically, I managed to expand this a little bit, so from now on it's already 1500 bytes of RAM, and now I have up to 750 bytes for program instructions and variables, and 750 bytes for that are shared between the program variables and the stack. And just a few words on how did I manage to do that in particular. So first, and the most significant thing that I did is I've moved all the messages that I have in my CMK computer into the progmem. So now they are no longer taking SRAM in Arduino Nano, but instead they are in the flash memory where the program code actually lives. So all of this kind of messages has been stored there. And also I've expanded, so I've tried to expand the memory size first to 2K, but it was like there were some errors because of sharing the memory between the global and the local variables, and eventually the software I've already written for my computer just stopped working properly, and there was some sort of an undefined behavior. And starting at this 1500s, that's the point where it still gives me a warning like that it might be unstable and things like that, but actually works. And again, like it's I have 250 bytes more for program bytes, which is significant, I believe. So I think that would be a deciding part in regards to the chess engine if I ever about to complete that, basically. So yeah, and also again, like now if I had in the previous attempts I had the board at the address of hexadecimal 20, which is 512 bytes from the start of the memory. Now I have this at the address of here's the source code for the chess program I'm developing, by the way. So now I have the board at the address hexadecimal 2EE, which is 750 bytes. So yeah, and currently if we just have a look at, so if I just compile and run my chess program again, it's not really a chess program, just a print board routine, and the routine to initialize the board array and the piece square tables, like positional evaluation. So here I actually have 286 bytes, but if I get rid of the print board routine, which is only used for debugging, so it's not going to be used on when it comes to kind of real usage, it would be just taking the board position as an input and giving the move as an output. In that case, it would be fairly enough to I will strip I don't know how many bytes, but yeah, quite around 100 bytes apparently, even more probably, for the print board routine, which is available down below here. And just to give you an idea how this kind of works, so if I just copy okay, so I'm not showing my real Arduino at the moment, so yeah, let me just go to the emulator instead. Right, so yeah, let's just consider this one, and if I say FFFD, and here just maximize the monitor and paste and send. Yeah, now it takes a bit longer to upload the data because it just takes more space, like more bytes, but again, like on the real hardware it's still instant. So let's have a look. If I just run the program, it will now print the chessboard, right? And yeah, a bit strange thing to say at least is that for some reason in the emulator it just doesn't always print the memory properly. Yeah, I'm not sure why exactly is that happening, because when I'm doing this, I can't show you my Arduino, but at the moment, but I can just load exactly the same program and send it to my real hardware, and when I run, yeah, it gives the output. In this case, like, the real device gives absolutely fine output. However, well, for some reason, I'm not really sure why exactly that is happening, so I still need to make a bit of research. So here, kind of doesn't work that nicely. So yeah, I still need to debug that. But again, on the real device, it kind of works like a charm, and that feels like fairly enough for me to work. I'm pretty happy that it's working on the real hardware. So. I have no idea what's going wrong with the emulator, so probably, I have no idea, to be honest, like why this is so in the emulator. But in the real hardware, as you can see here, works perfectly well. And a bit of a summary, I can already provide a bit of a summary. So like, when I've been staring at my computer for quite a bit of time, so again, like, just to give you an idea how it looks like, how the real hardware looks like. So I have the 4x4 keys keypad, the LCD shield, and Arduino Nano. It's here, it's not seen on the picture, but it doesn't matter really. And it felt to me like there should exist something similar to this. Definitely should have existed. So I couldn't believe that I've invented something on my own. And after a bit of research, I've realized that what I've been trying to invent is already has already been invented around 45 years ago, and that is known as the KIM-1 computer by my favorite MOS technology company, so the manufacturer of the 6502 processor. So this is the very first single board computer that was actually created in order to introduce 6502 chip to the broad community, and just to provide an instant opportunity to play around with the chip, so the user could have entered the 6502 machine codes in hexadecimal, and you just know the similarity. You see, like, the similarity is very you can't argue that there is no similarity. It's literally the same thing. So keypad to enter this hexadecimal codes, and also some command buttons, and I got some command buttons as well. It's very similar, to be honest. Well, the display is different. So display was like 7 segment LED elements, so it was just 4 digits basically. It wasn't graphical really, but anyway, and people already did write absolutely amazing software for this computer, including chess, and there is a very fantastic and very popular program that is called MicroChess that is running on this computer. I didn't yet try this, and I'm going to be covering that on my chess programming channel in greater details. But again, like, when I saw this, I realized that this is exactly what I was thinking about, even though I had no idea that KIM-1 actually existed. It was a really fantastic experience to discover that KIM-1 actually exists out there, or existed in the past. But what is even more interesting, so I've been reading through this Wikipedia article just to make sure that I'm clear in regards to the specification, and what I was really surprised about, that it has actually 1K of RAM. The standard amount of RAM is 1K of RAM, is just like CMK computer had before this extension, like before I started extending the memory to 1500s. So this is the first similarity. My CPU is obviously inspired by 6502, but much worse, and that's already now, like, when I'm writing a chess program, I really feel that, like, the lack of indirect addressing, for instance. So yeah, it's a bit of a pain, but I'm still interested in how far am I be capable of going with the current setup that I have, just out of curiosity. But what I've realized so far, that actually creating the real 6502 machine emulator, and not just some imagery machine, but KIM-1 in particular, with the only difference that I want to have the LCD display instead of this LED displays. And quite a fun thing that there is a guy who has already done that. not exactly in the way how I want to do that, but still. So he made an Arduino based project that, and this is how the end result device looks like basically. And it's as far as it's based on Arduino, so there is I've already downloaded that somewhere. So KIM-1 summary details. Yeah, so somewhere here I remember I saw like summary, yeah, memory map. I don't remember where exactly. Yeah, there was just, well, probably let me just show you my top secret project that I'm currently preparing to develop. It's just those files that I've grabbed from this guy. I'm not sure even what's the name of the guy. He didn't seem to provide the name to say his name actually. But anyway, when I would be releasing my stuff, I would definitely give a credit to this website, which is absolutely fascinating resource. So yeah, the code name CMK, Code Monkey Kim, not Kin, but Code Monkey Kim, keyboard input monitor. So yeah, in here he has a 6502 emulator, and also this is the file to flash into the Arduino, assuming his hardware setup. Well, I would be having a different setup, but anyway. And all of this stuff is actually based on existing 6502 processor emulator written in C by Mike Chambers. Yeah, it's back from 2011. Yeah, but it seems to be very fascinating 6502 emulator, and the source code is incredibly clean and clear, and I just love this at the first sight when I just saw this. And also it's cycle accurate, which is really fantastic as well. And it has a very simple but yeah, powerful, how to call this, basically interface, like API maybe. I don't know how to call this properly. So in this usage part, so all you need, like, just provide a couple of external functions. Also we have a function to kind of like fire the function after the instruction has been done. It's probably going to be useful for debugging, and yeah, lots of things. So what this guy has done already, so he has adopted this 6502 emulator to mimic the real KIM-1 and to make it work with this hardware, which mimics the exact KIM-1 experience. But as far as I'm not really looking for the exact KIM-1 experience yet, but instead I'm just looking for something that is more similar to what I already have. And well, definitely I'm going to be using exactly the same hardware setup. But I just want to make write code in 6502 assembly and turn it into machine codes, and I'm not sure how exactly the matter of sending the bytes to the device where serial port is done. So if I'm not mistaken, here he actually does it somehow so it's already the part of the RAM basically. So he writes the program in 6502 assembly to get the data from serial port. So it's a bit overwhelming to me at the moment, but again, the fact that it is possible is already kind of inspiring enough and very exciting. So yeah, now I can kind of like announce that the next thing that I'm gonna be building using this exact hardware that I have here would be the 6502 processor-based computer, like the emulated version, but nevertheless it's gonna be quite accurate. And yeah, so I think that computer is going to be even more epic than this my very first attempt of creating this CMK computer. So we'll see how it goes. And yeah, but before this project is about to come, I really need first to get done with my chess programming, just to see how far would I be able to go with that. So if I ever succeed with that sort of a thing, I will definitely let you know, guys. So thanks for watching. Until the next time, and take care.